I'm going to work through the quiz 12.2a. And we're given a standard form of a quadratic equation here, and we want to get it into these other forms. So first of all, I'm going to find the y-intercept by plugging in 0 for x, and you get the constant term, which is 39. So 0, 39. And we could try to factor this, but these are some big numbers, so I'm gonna actually go for vertex form. And to do that, I'm going to factor 4 out of the quadratic and the linear terms here. Leave a little space. Take b over 2 squared, so b over 2 squared would be 16. So I'll add and subtract 16. Then multiply the 4 times the negative 16. So I end up with y is 4 times x squared plus 8x plus 16 minus 64 plus 39. Factor is going to be x plus b over 2 squared. And then negative 64 plus 39 is going to be negative 25. And so that's our vertex form. Y is 4 times x plus 4 squared minus 25. And our vertex is going to be negative 4, negative 25. I'm going to find my x-intercepts from that by plugging in 0 in for y. And solving here. So we get x plus 4 squared is equal to 25 over 4. Take the square root of both sides and you get x plus 4 is equal to plus or minus the square root of 25 over the square root of 4. And then subtract 4 from both sides, and we get x is negative 4 plus or minus 5 over 2. I'm going to split that up, and actually instead of negative 4 I'll think of it as negative 8 over 2. So x is negative 8 over 2 plus 5 over 2, which comes out to be negative 3 over 2. That's one answer. And the other answer is negative 8 over 2 minus 5 over 2. Negative 8 and negative 5 is negative 13 over 2. So I got two x-intercepts. X equals negative 3 over 2 and x equals negative 5 over 2. Now, I can get factored form through my x-intercepts, and here's how I'm going to do that. So I know x is equal to negative 3 over 2. Actually, let me just do this. So factored form can be written this way: a, which is 4, times x. So I have negative 3 over 2, so it'll be plus 3 over 2. And I have an x equals negative 5 over 2, so it'll be x plus 5 over 2. So I'm good with that for factored form. There's other ways to write out factored form as well. The 4 is 2 times 2, and I can distribute that in this way. So if I multiply the first set of parentheses by 2, I get 2x plus 3. If I multiply the second part by 2, I get 2x plus 5. I'm noticing that I made a mistake. I copied it down wrong. I put negative 5 over 2, but when we solved, we got negative 13 over 2. So let me fix that. So make the factor positive 13 over 2, and this would be 13. So either of these are good factored form, and if you want to double check, make sure it works out, you can multiply it out, and you'll see that we get standard form from that. Okay, so I went a different route here. You could have went ahead and factored first and got, if you went and factored it, you'd get the second one, the 2x plus 3 and the 2x plus 13. And then from there you'd get your x-intercepts that we got, and that works. And then you can get the vertex and find vertex form. I went a different route. There's different ways to do this, and they're all okay. What the bottom line is that you're getting these answers. So for the graph, let's see here. So the center here is at x equals negative 4. We have y-intercept at 0, 39. A matching point on the other side at negative 8, 39. We have a vertex at negative 4, negative 25. And then we have x-intercepts at negative 3 over 2. Negative 3 over 2 is like negative 1.5. And then the other one is negative 13 over 2. That would be negative 6.5. So we have 5 points for our graph. Domain is all real numbers. It's not a word problem. Range is all y values bigger than or equal to negative 25. It's increasing when x is greater than negative 4. Decreasing when x is less than negative 4. We have some points to fill in here. Let's see. So when y is 0, that's your x-intercept. So we have two of those. We got negative 13 over 2, and we got a negative 3 over 2. The vertex is at negative 4, negative 25. And we got to find the others. So notice that negative 3 is 1 to the right of the vertex, and negative 5 is 1 to the left. So we're going to have the same y value no matter what. I just need to figure out what that is. And I'm going to plug in negative 5 into factored form. So 2 times negative 5 plus 3 times 2 times negative 5 plus 13. And we get negative 10 plus 3, which is negative 7. And negative 10 plus 3, which is 3. Just double checking here. So negative 10 plus 3 is negative 7. Negative 10 plus 13 is 3. So negative 21. And there's some other points. Axis of symmetry is x is negative 4. Okay. Now for solving, using 3 different methods. First one we want to solve by using the quadratic formula. A is 3, B is 6, C is 2, and the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then just simplify that. Six squared is 36. Negative 4 times 3 times 2 is going to be negative 24 all over 6. And 36 minus 24 is 12. And the square root of 12 is the same thing as 2 square root of 3, because 12 is 2 times 2 times 3. And then I'm going to reduce the fraction. I'm going to look at the negative 6, the 6, and the 2, divide each of those by 2, and get negative 3 plus or minus the square root of 3 all over 3. And that's our answer for the first one. The second one we need to solve by factoring. And so first thing you want to do is set it equal to 0. Second thing you want to do is start with a positive, make a positive, and I do this by just multiplying everything by negative 1, and so it just changes the signs of everything, so both sides by negative 1. So when I multiply the left side by negative 1, I get positive 6, negative 13, positive 6. When I multiply the right side by negative 1, 0 times negative 1 is still 0. And then go ahead and do what I taught about factoring. So I'm going to multiply 6x squared and 6, that's 36x squared, and negative 13x. So we're looking for two terms that multiply to negative 36, sorry, positive 36, and add to negative 13. So you go over the factors of 36. You got 36 and 1, not going to work. You got 2 and 18, no. 3 and 12. Doesn't seem like that. 4 and 9. 4 and 9 add to 13, so negative 4x and negative 9x. Split up the negative 13x to negative 4x and negative 9x. Factor by grouping. So I'm going to factor 2x out of the first two terms. And then a negative 3 out of the last two terms. And then you notice if you look at the two remaining terms, they both have a 3x minus 2. So I'm going to factor out 3x minus 2. And I'm left with 2x minus 3. Now it's factored. Then you set your factors equal to 0 and solve, and you get two answers. First answer is 2 over 3, and the second answer is 3 over 2. And our last problem here, I wanted to just solve by completing the square. And so I'm going to put parentheses around the x squared and the 5x, factor out a, which is just a 1, and it's not going to change anything, and then find out what b over 2 squared is. So b is 5, so b over 2 squared is going to be 25 over 4. So I'm going to write x squared plus 5x plus 25 over 4 minus 25 over 4, all in the parentheses, plus 1, is equal to 0. Then I'm going to multiply the 1 in front, the a, times our fourth term in the parentheses, and get x squared plus 5x plus 25 over 4 in parentheses minus 25 over 4 plus 1. Instead of writing 1, I'm going to write 4 over 4 so that I can work with our fraction here. I'm going to factor the three terms in the parentheses using the shortcut, which is always going to be x plus b over 2, in this case 5 over 2 squared, and then we have minus 21 over 4 equals 0. Add 21 over 4 to both sides. And then take the square root of both sides. Don't forget the plus or minus sign. And then subtract 5 over 2. And in this case, the square root of 21 can't be simplified. And so I'm going to write this as one big fraction. X is negative 5 plus or minus the square root of 21 all over 2. And that's our answer for the last one.